Welcome everyone. I'm sorry that was a bit loud. This is my second talk since the end of COVID, so I need to get used to speaking in front of the crowd, not being in my own safe room. So I hope it will go smoothly. Welcome at my presentation about the Kotlin ecosystem at the backend side. So first of all, a small introduction about myself. I'm Paulien van Alst. You can follow me on Twitter under this Twitter handle if you want to. Tweeting some stuff about conferences and, well, Kotlin mainly. I'm a software engineer at OpenValue. We're a small software engineering company in the Netherlands where we help companies to do their innovation tracks. We specialize in various topics. Kotlin is one of them, and we love to share knowledge, so you might see us on stage soon, often. Yeah, so from the Netherlands, already said it. I'm a co-host at the Barcoding podcast. You can find us on any podcast platform you want. We're talking about, well, software engineering because we're in love with our job. And the fun fact is that we have a confusing hashtag which is coding_bar. I'm in love with programming as well. I might do it a bit too much, but that's no harm. And as of 2020, I'm a Google developer expert in Kotlin. So that's about the marketing stuff. Now let's talk about serious stuff. What are we going to talk about today? So first, I will try to answer this question: why even build a backend in Kotlin? I suppose that lots of you are coming from the Java world, feeling fine there, but as you're in this room, you're interested and curious about Kotlin. So we'll give you some arguments that you can give to your team back home or your manager. Challenges coming from Java. If you come from Java, like I did, there might be some challenges when you use Kotlin and remain in the Java ecosystem. So I will point that out so that we can finally introduce everything where we can choose from to build a Kotlin application with using the Kotlin ecosystem. So why even build a backend in Kotlin? By a raise of hands, who of you has pushed Kotlin code to production? Okay. And who of you is then still using Spring? And who of you is using something else? Okay. Vertex? No? Micronaut? Jfokus? Okay, some few. Yeah. So I hope I can learn you new stuff. So the advantages of Kotlin are mainly the safety of your code. Nil safety, for instance. Kotlin knows non-nullable type and nullable types, which makes it very easy to have safe code bases. However, there are still nullable types, so you can still make it work to have your null point exceptions, no worries. Immutability, Kotlin embraces immutability, which means that if you're working with Kotlin, you should embrace it as well. Otherwise, you will be writing Java code but with a Kotlin flavor. And Kotlin will enable you to write readable and thereby maintainable code. You all know the saying that we write code once and read it thousands and thousands of times. But we are not reading it ourselves. Our teammates are reading it, our future teammates and our future selves as well. And that's, I think, the readability is one of the most important arguments to use Kotlin. Of course, you can write readable code in Java, so don't be lazy there, but Kotlin will help you out there. The most distinguished argument would be concurrent programming using coroutines in Kotlin. Java don't has any kind of that feature. Project Loom may be coming up. So if you want to do concurrent programming, Kotlin is the way to go. And as you will see today, with Kotlin, you're able to build lightweight applications. So that's pretty awesome as well. Last but not least is the use of domain-specific languages, DSLs. You will see today during the talk that lots of the Kotlin ecosystem is using DSLs a lot. And that means that, again, your code is becoming more readable and more maintainable. Our job is to make complex things simple, right? It's really awesome to do complex things. People think you're smart. But in my opinion, you're smarter if you're able to make those things simple. I think that you're smarter if your product owner or business analyst is able to understand your code and maybe even review it. So that hand in hand together, you can work out that your code quality is pretty good. Challenges coming from Java. Imagine you're working on this Java applications, you migrate to Kotlin because that's the hype and you want to jump on the train, which you don't fully understand Kotlin yet, which is okay. You will see that Kotlin and Java, it goes well. It's one of the main selling points of Kotlin, the interoperability with the Java world. But you will and might face some challenges. Why? Because the idioms of Java and the idioms of Kotlin are not the same. Some of those challenges are that lots of Java frameworks and library are using reflection. And that clashes with the fact that Kotlin likes or embraces immutability. So you will see during this talk, or maybe you even experienced it, that you need to tweak it here and there. If you remain in the Java ecosystem, you will also see, or maybe you already know it, but you will experience it a bit more, that Java frameworks and libraries are proxying classes a lot. Clashes with the fact that Kotlin wants its classes to be by default final. It's okay, you can make them non-final, Kotlin, that's still alright. But it's not really how the language was designed for. And of course nullability. If you're using Java libraries into your code base, you will see that all the types are nullable, which is a fact. All the Java types are nullable. So if you're using that library and the types in that library, they will be nullable. Which means that you need to check on nil throughout your whole application if you don't deal with it properly. And that's something you don't want to if you're choosing for Kotlin. However, don't be afraid. It's fine. And those challenges are solving themselves because the Java ecosystem is jumping on the Kotlin train. When I start back in 2017 using Kotlin, there were much more challenges. It was much more awkward to use Kotlin. And that awkwardness is fading away. But I still want to point them out. So what we are going to learn today is that Kotlin is more than a language. If you choose for Kotlin, you not only have to choose for only the language, you can, but you don't have to. As Kotlin is an ecosystem in its own. And it's a valuable ecosystem that is accepted by the industry and that you can use. So where to choose from? There it goes. Application frameworks. We are building backend APIs and other backend applications that we can think of. So application frameworks will be the most important part. Most of us really like dependency injection, right? In version of control, we use it way too many. And still in Kotlin you can use it way too many. Database libraries. Lots of our applications nowadays have data. Our world is about data and thereby databases. And of course our communication part, HTTP libraries. Those will be the 4 topics that we will approach today. You will see what you can find into the Kotlin world. Let's go. Yes. So what about the application frameworks? The first suspect in the Kotlin ecosystem is Ktor. Ktor has been made by JetBrains, so of course they will say go for Ktor if you choose Kotlin, which is a proper choice. Other ones are Micronaut and Quarkus, and I don't want to harm anyone putting them side by side, claiming that they're kind of the same, but regarding for Kotlin they're kind of the same. So sorry for the Quarkus developers and Micronaut developers here. HTTP4K, another very nice Kotlin application framework. GraphQL, you can build pretty good GraphQL APIs if you want to. And of course, Spring. Yes, Spring is also part of the Kotlin ecosystem. I'm going to tell you why. Ktor, let's start with it. Lightweight applications, fast in startup, the dependencies are not that big. So it's pretty cool. You can configure your whole application using DSLs, so making your code a bit more explicit. However, it can only be used with Kotlin. So if you're working on a hybrid mode, Java and Kotlin, you can't use Ktor as far as I know. This is how a code snippet would look like. I hope it's big enough on the screen. This is how the main function will look like. So it's different from the Spring Boot applications, where you only have this very small main function and then the annotation will do it for you. In that main function you can initialize your database and of course tell which server, application server, you want it to run on, which in this example is Netty. And then if you want to inject your business logic, you can just assign some modules to it, which in this case is the recipes module. One of the other configurations that I like the most is that you can wait until the application is all started, if all the above components have started and healthy. I wouldn't see a case when you don't want it to, but at least it's explicit. This is how my business logic looks like in this small example. It's an extension function on the application class of Ktor, where I can just tell my application that all the serialization has to be done in Jackson with the configuration accordingly that I want, and I can just define my API endpoints, declaring functions here. So this is the DSL that Ktor will offer to you. Let's have a look at how my API then looks like. If you have in mind how your Spring API classes, controllers or endpoints, however you want to know them, this would look like a bit weird because it's just a function, an extension function on the class route, where you can declare your whole API in a declarative way, I would say. Where my get endpoint is listed over here, which is part of the API interface over there. And then in between the brackets of the get, I can just state all my business logic. That was about Ktor. Let's have a look at Micronaut. And everything that I'm telling you about Micronaut will hold for Quarkus as well, just for the Kotlin part, of course. Micronaut will enable you to write functions. It runs on GraalVM. And what's really good at Micronaut is that it has a CLI where you can initialize your whole code base before you start developing your Micronaut application. And if you do so, you have 3 languages to choose from. Java is the default, of course, but Kotlin is one of the languages that you can choose, and will generate actually Kotlin code for you. This is how then the default Kotlin code looks like. This is the request handler in this Micronaut generated function. It looks like proper Kotlin code, no problems here. However, the domain class that it generates is in my regards not a proper domain class. This is a domain class in Kotlin. You would like to declare it as a data class and have non-nullable types. So I don't really know why Micronaut did it like this, but just be aware of that. Maybe they have improved it since I created this, and since I worked with Micronaut, but this was the case a few months ago. Let's have a look at HTTP4K. This is one application framework that I really like the most. I will tell you why. You can build your normal HTTP APIs on it. We can also go serverless with HTTP4K. It's entirely designed for Kotlin, with Kotlin, and those applications are pretty lightweighted as well. Yeah, so you can build your server as a function, that's fine. This is how the code will look like. We'll focus on the upper block. The second function is the main function, which will look a bit like the main function of the Ktor application. It's apparently how we as a community wants it to look like. And then let's have a look at how I can declare my API there. I have this routes block where I can declare my API using a DSL. I can bind my URL to a get method, and then using the word to, I can bind my business logic with it. If we have a look at the business logic and what the endpoint should return, we'll see something that you might not recognize. At least for me, the first time I worked with HTTP4K, it was new. I'm using an ingredient lens of ingredient. An ingredient in this case is my API object that I want to expose. So what is a lens? Well, a lens is what HTTP4K uses for serialization. Lenses means that it uses a copy method to fill in the class that it will return as a JSON. So instead of using reflection and then modifying one object, it will duplicate it until it's completely populated. It means that it doesn't break immutability, but it generates lots of classes. But it's efficient and it works fine. As I said, Spring is also part of the Kotlin ecosystem, at least in my opinion, because Spring is really working hard to support Kotlin. It's true, but it's still a Java application framework to begin with. However, Spring Webflux, and thereby also the coroutines, are feeling really like proper Kotlin application frameworks. The big advantage of Spring is that this is an industry standard. It's very mature. It will work. It will work definitely. The other one as well, but for Spring you know it for sure. And as I already said, it's approaching Kotlin more and more. If you're using Spring together with Kotlin, you need to make sure that you tweak it a bit. The first thing is that in your build plugin, this is a Maven example, but you will have to do the same with Gradle. In your build plugin, the Kotlin Maven plugin, you need to configure it to do the nil checks. Spring is a Java application framework. All the types related to Spring will be nullable. If you want your code to check if nullability or null safety is guaranteed, you need to set this configuration flag. If you generate your code with the Spring IO initializer, you won't notice it, but it's there. So be aware of it. It's important to know. Lots of people don't know actually it's there. Let's have a look at Spring code then. This is how a Spring repository, for instance, looks like. And this is why I said, like, Spring Webflux and coroutines, that's already, a valid Kotlin candidate, as I can extend my repository from the coroutine CRUD repository, returning a flow object. This is the integration layer with my database. We're going to talk about it later on today. But it already shows that Spring is really hopping on the Kotlin train. Other thing is, you can just enable also all your reactive repositories, which will enable you to use that concurrent programming. So that's pretty cool. Another thing where Spring is really hopping on the Kotlin train is Springfree. Springfree is an experimental project from Spring, where they try to design a new DSL to configure your application. It has a Java foo and a Kotlin foo. So that states out that Kotlin is considered by Spring for sure. So that means if you're using Springfree, you don't need to use any annotations, if you want to, of course, and that you can use a DSL. If you are using Springfree into your application, the configuration of your application will look like this. So no @springboot application, annotation, whatsoever. You can declare it again, your application, like a normal code block. So it's a web application in this example, where I can define my JSON serialization and where I can define my routes like this. I think now you can distinguish a pattern that you will see throughout this whole slides. So that the configuration of my application using Kotlin will change regarding to Java. Let's have a look at GraphQL. GraphQL is, at least in the Netherlands, pretty popular. And if you're using GraphQL together with Kotlin, there's a HTTP4K GraphQL module. I only know it exists. Discovered it lately, didn't play around with it. At a project I used the Expedia Group Kotlin implementation, which is actually a wrap around the Java implementation. But it will work fine. That's just about GraphQL. Let's have a look at dependency injection. We're doing that a lot because we want inversion of control and we want testability in our applications. Candidates for dependency injection in Kotlin are Dagger, Coin, and of course Spring. Dagger and Coin can be used in all those others application frameworks than Spring. If you're using Spring, you should stay on Spring. Let's have a look at Dagger. I haven't really worked with it, but it's definitely a candidate. However, you will see Dagger more in the Android part of the Kotlin world than in the backend part. It's based on Java EE. It does code generation during compile time for all the dependency injection. That means that you have validation about your injections. So no runtime exceptions, it can't find a bean. And there are some compile options to be in control as a programmer regarding that code generation. Coin starts with the K, which means that it's really part of the Kotlin ecosystem. It works with interfaces to declare its beans, where you can choose the implementation strategy. You can use modules to organize your dependencies, and it knows the usual scopes that you will know for dependency injection. Single factory scoped. You can use annotations with Coin. If you rather not, you don't have to. This is how Coin code will look like. In this example, I have a recipe service which gets a recipe repository injected. And if I want to configure that properly in my Ktor application, this is what I'm doing in my Ktor application. At starting, I can define my recipe module. This is my Coin module, not my application module. To have those components, a single bean of type recipe repository, and a recipe service which get a recipe repository injected using the method get, which by type inference will use the recipe repository declared in this module. I also want this module to be created at start. It means that the beans are there at the moment the application is started. If I want to inject that, use that recipe service, for instance, somewhere in my routing is not a controller anymore, so that's a bit confusing, maybe. It's just a code block where I want to inject some dependencies. I can do it using this syntax, by inject. And then I will just have the recipe service bean at my disposal. Let's have a look at Spring. Spring dependency injection in Kotlin, this is where it starts to get a bit awkward, but it works. It's annotation based, you all know it, I guess. However, Spring beans, or no, let's just say it like this. Classes representing Spring beans shouldn't be final. And but the main advantage is that Spring is fully testable. All the testing frameworks are supporting Spring nowadays. And as testing is one of our biggest part of the our job, it's pretty important. And as I already said, at Springfree, now you can, if Springfree gets less experimental, you can use a Kotlin configuration DSL. However, for beans, I think it's already in there. So let's have a look at my Spring beans, how I like to write them down. I'm here using the add component to declare it's a Spring bean. And as you will see, my class is declared as open. As I said, classes in Kotlin are by default final, and Spring can't do its trick if it's a final class because it's proxying it. So I declare it open. If I have an interface, I'm fine, of course. I can just use my repository annotation here and it's doing its job. And I think the people here working with Kotlin and Spring are like, I never use that open keyword. Why does it work with me? Well, it works because someone did it for you. There is, again, a Kotlin compiler plugin which Spring will sneakily put into your Maven POM if you generate your code. And that compiler plugin is called Spring. Spring will tell the compiler which classes are Spring beans. So those are the classes annotated with add component, add repository, add service. And it will tell the compiler even more. It will tell the compiler which classes should be marked as open. Because in your compiler plugin, you can add this dependency, which will say all the Spring beans are open. And then the magic trick is done for you. So by a raise of hand, who was not aware of this? Yes, so now if you learned today at least something, thank you. I don't like this. I removed this in my projects. Why? Because I want my teammates to learn something and to know that the beans should be declared as open, or the classes representing the beans should be declared as open, so Spring can do its tricks. If you're working with Spring, you need to understand it. In order to understand it, your code needs to be explicit, and there shouldn't be any compiler tricks there. Classes are only open for the compiler, not for you as a programmer, I think. So this very confusing. Go back home, remove it, and declare all the classes open so your teammates can learn from it. That would be my advice. HTTP libraries. We're communicating a lot through HTTP. HTTP4K comes back here. HTTP4K can be used as a HTTP client in Spring application, will work very fine. Ktor HTTP client, and of course we have the Spring REST template. So let's have a look at HTTP4K. Lightweight, very lightweighted client. It's full Kotlin, and it looks like this. This is how a client using HTTP4K will look like. You can use an HTTP handler, which you can choose which implementation you want. On the HTTP4K site, I will advise you some of them regarding your wishes, and you can just do your request like this. On the line above, you will see that I'm using a lens again to serialize my objects. Then the Ktor HTTP client. It only works with Ktor, it's full Kotlin, and it will look like this. It's not that much of a difference with HTTP4K, to be sure. You have your HTTP client, you have some utility functions to check if your status is successful, everything in the range of 200. And you have much more utility functions to check your status there. You can specify the method that you're doing on the URL, and that's about it. Pretty simple, right? So I just said I can use HTTP4K clients in my Spring application. Why would I even do so? Well, because I have some kind of small OCD and I don't like this code snippet I will show you. Because the Spring HTTP client is pretty cool, it works fine, it integrates with the rest of Spring, and it really has solid deserialization, also with Kotlin. You can define your REST template like this, declaring a bean. However, this is where it feels awkward for me. I'm building this whole Kotlin application, really proud of myself, and then I need to write this down. Because the Spring REST template will only work with the Java equivalent of the recipe class to do its deserialization. I don't really like that. So I switched to HTTP4K client in my project. But it's personal. And it was fine actually, it was doing its job, but we needed a lightweighted one as well. Database libraries is the large part of it. Exposed, also developed by JetBrains. I think it's pronounced Juke or Joke, I never know. And then Spring. Points of attentions. If you want to choose your database library, and this is not Kotlin related, but as Kotlin libraries tend to have a DSL, check if the query language is suitable for you. Don't be lazy there. Don't do a proof of concept based on a simple insert or a simple select, but pick the most difficult query that you will imagine in your application and do your proof of concept with that. Because if you're choosing a DSL, it should suit your needs, right? And if you're using coroutines, make sure that the library is reactive or asynchronous. Otherwise, your whole application will be reactive or asynchronous or whatever you want, but the blocking part will be at the database communication part, which blocks your whole nice thingy. Also make sure that the database is running underneath as a reactive driver. Otherwise it won't work either. Although they have nowadays a lot. Let's have a look at Exposed. Exposed has a DSL. It's supporting lots of database dialects, mainly, as you can see, relational databases. This is how you can use exposed in a Cato application, for instance. You can just connect to your database using Hickory, still goes fine. And if you don't want to use Flyway for your database migration, you can just initialize your schema using exposed. However, I would still advise to have Flyway because of versioning, but that's a matter of taste. If you want to go fast, this is a very valid option. Yeah, connect to Hickory. Now let's have a look at how the code then looks like, and now it gets a bit more complicated, I guess. You can have declare my table that I have in my database schema. Oh yeah, I can declare every row as being an entity which has an integer as an ID, or anything else, because integer has a valid has a limited scope, but in this case it would suffice. And that row is referring to a table which also needs to have the same type of ID, which has a name and columns and stuff like that. This is how you tell your application how your schema will look like. So this feels, at least for me, a bit like lots of code to declare it, if you're used to the database entity classes of Spring. But it works, and it looks pretty fine. Then let's have a look at the how we can query on the database, because we're choosing Kotlin, so we're choosing DSLs. So to do an insert, we can just call the recipe table object. We don't need to initialize it, it's an object, and then doing an insert. We need to use a transaction block to have our transaction, our database transaction to the database. Let's imagine now we want to retrieve something, then we need to call the database access object to find any rows in the table. There it goes. My animations are a bit slow. Where the values in the column name is equal to the name that I'm looking for. Once a transaction is done, I can cast it to a sequence, which you should do if you're using large collections, and you can go on with your Kotlin code. Now let's have a look at joke. Still don't know it. It's from the Java world. People might know it. People might use it already. And actually, I haven't worked with it, but oh, there it comes. It has a Kotlin integration as well. It's no DSL. It's more of a builder pattern if you write down your queries, but it works fine, and people work with it in the Kotlin world. Now let's have a look at Spring. And yeah, there again, we'll see Spring is still Java. So if you're using Spring together with Kotlin, you need to add another compiler plugin, which is called GPA, which will tell the compiler which classes are annotated with a GPA bean, at entity, at table, and so on. And this one you can't work around with it with code. This one you should know that you need this to add this dependency, otherwise it won't work. Your classes won't get populated. Why? GPA, when it wants to populate its class with the values from the database, it will instantiate its object using the default constructor, and by reflection injecting the values into the bean, into the entity class. That won't work with Kotlin. With Kotlin we declare our entity object as a data class with full R constructor, maybe with some optional parameters, that's fine. So we don't have that default constructor. So you need a compiler plugin, yeah, there we go again with the magic, to have a no R constructor to be able, that GPA is able to populate the values. Oh, the default constructor won't be accessible throughout your codebase. It's only accessible for GPA. So this is why you might not know that it's there. So this is how an entity class will look like. It's a data class. So in your codebase it will just look like a data class with one single constructor. Having a nullable ID, because your ID, if you insert your entity for the first time, will be nil, of course, and will be set afterwards. But you can still use your immutable, how do you say it, properties like name it here, there. So as I said, GPA will create for you your default or no R constructor to be able to use it, to fill it. And the default constructor is not accessible in the codebase. this is also, you can also use the add table on a data class, that's still fine. And as I said, my repository, you already saw this code snippet, but now it's in the part where we're looking at the ORM. You can still use the interface, declare an add query on it, it will still work fine, and in this case it even returns a proper Kotlin object, which is a flow. Yeah, the coroutine CRUD repository, but I already said it. So to summarize a bit, there's a lot to choose from. If you're going to Kotlin, you don't need to remain in the Spring ecosystem. However, as you have seen, your code bases might change. It looks different than what you're used to, or that you might have been used to. But I would say embrace the Kotlin ecosystem. If you're embracing the Kotlin ecosystem, you will embrace Kotlin as it's full of power. Welcome to the welcome to the Kotlin ecosystem. Any questions? Left? Yes? Okay, good question. What do I use for testing? Let me see. I could have put it in there. I'm using the mock framework, M-O-C-K-K. Why I'm using that? Because at least for the mocking part is doing the proper Kotlin tricks. And yeah, for Ktor, for the integration test, it has its own testing framework. So there it goes well. HTTP4K has its own integration test framework as well, which suits the integration part fine. Mockito can still be used as well with Kotlin. Yes. Good question. Other questions? No? Oh, again, yes, go ahead.
You never mentioned Kotlin serialization. Is it
Yeah.
something you've tried, and what's your experience with it?
Using Kotlin X serialization? So the question is whether I use Kotlin X serialization and what my experience would be with it. Actually, Jackson works fine with Kotlin, so I had no reasons to step out. Is that a good answer? I haven't used it then. Yes.
What's your opinion on combining Kotlin and Java? Do you still do that, or you still do that?
Yeah. So the question is what my opinion is about combining Kotlin and Java. No big objection about that. I'm not against Java. I have to do it a bit to be opinionated in the talk. But combining Java and Kotlin is a very valid thing to do, especially if you're migrating from Java to Kotlin and that you have a migration strategy. So my advice would be, if you're using Java and Kotlin side by side in the same code base, agree with your team what is in Kotlin and what is in Java. And if you're migrating, I've done a talk about it as well, make sure that you're doing it steps that the teammates can learn along. So migrate as along as you are learning the new features of Kotlin. But it's perfectly fine to combine them. That's also a big unique selling point of Kotlin, is that it works pretty well. But make sure that you understand Kotlin, make sure that you understand Java, and what the tricks are that you need to make. Understand those tricks to be able to do it. Yeah, but it's fine to do. Other questions? Then we're done, guys. Thank you for your attention.